Hey scholars, welcome to chapter 18, looking at air pollution this week. And that's what our main focus will be. Then we're going to move into water pollution in chapter 20 next. But let's take a look at chapter 18 first. And we start with our case study, which has to do with South Asia's massive Asian brown cloud. And basically, give you a little history about this and what it's made up of. But the causes of it are mostly from industry as well as deforestation. So it says the cloud actually measures 3 kilometers or 2 miles, as far as we're concerned, thick, and hangs at an elevation of about 1 to 3 miles. And it covers the area about the size of the continental U.S. So exclude, Alaska, exclude Hawaii, but the continental U.S. That's how large this air mass is. About a third of it is dust, smoke, and ash resulting from drought and the clearing of burning of forests and planting crops. And the rest of it's coming from industry, which is made up of metals such as mercury, lead, lots of organic compounds, fly ash produced in the burning of that coal, diesel, and other fossil fuels, motor vehicles, and also homes. That's kind of the makeup of it, and also the causes. The areas that are in impact, obviously, are mostly Asia itself, specifically India and Bangladesh and the industrial heart of China. But the problem comes with the connection to the world, where obviously air masses don't just sit still, but they do move around. And it said, first of all, let's talk about the impacts of this first. It says 7,000 premature deaths every year are caused from this cloud, which is kind of a very, very scary stat. But the thing about it is it does move around. It says in 2006, the U.S. satellite tracked the spread of the dense cloud of pollutants from northern China to Seoul to South Korea, and then all the way across the Pacific Ocean to us here in the U.S. It says the U.S. Environmental Protection Agency, the EPA, estimates on certain days nearly 25% of particulate matter, 77% of the black carbon, and 33% of toxic mercury in the skies above Los Angeles, California can be traced from those power plants of China. So that's kind of the scary part about it, where one part of the world can be doing some major damage to a totally different part of the world with either now even realizing it or just by the way that they're living their lifestyle. So that's kind of the Asian brown cloud. There's what it looks like from a satellite image. Kind of a scary, eerie, gray, greenish, gray, brownish look to it. And this is kind of what it looks like. This is in Shanghai, China in 2004, kind of sitting over top of Shanghai. So let's get into what is the nature of the atmosphere itself before we begin to look at how air pollutants actually affect that. So let's take a look at the atmosphere itself. So the atmosphere varies in 2 distinct ways. The first one is the density, which is the molecules per liter, which means the lower the atmosphere as far as close to the Earth, that means they're more dense, they have the higher density than the atmosphere the furthest away from the Earth. So we're going to take a look at also atmospheric pressure, which is basically stands for mass per unit area in a column of air, which again is very similar. We have the higher pressure near the surface of the Earth, and the further away we get, the less pressure we have. So let's take a look at the individual layers, which we're going to talk about in a second. They look like this. And we're going to talk about each one of these. They actually just mostly these two, since we come in contact with those the most. And those have the most impact on us. But we'll reflect upon this image in just a second. So the one we're going to look at first is the troposphere. It is the one closest to us as far as the Earth goes. It's 75 to 80% of the Earth's total air mass. It is the one closest to the Earth, and its makeup is about 78% nitrogen, 21% oxygen. So there's other molecules involved, but those are the major ones. The rising and falling of air currents, that's how it's really affected. The weather and climate all are consistent in this layer, and it does involve with all the chemical cycles: phosphorus, nitrogen, sulfur, carbon, hydrologic, all those different chemical cycles. The next one up, furthest, another layer away from the Earth's surface, is the stratosphere. And it's very similar in its composition to the troposphere, except for the fact that it has a lot less water than the troposphere. It also has a specific and a very, very important layer known as the ozone layer, which is made up of O3, the chemical compound ozone, and that is superly in charge of filtering UV radiation, which is very, very important for us to keep our skin safe, as well as our planet on a relatively constant temperature. So let's take a look at these other layers and talk a little more about those. One of them is the mesosphere. The last one, and the furthest one away from the Earth, is the thermosphere. And let's talk about the different lines going across here. We have in red temperature, and so I'm going to explain why temperature kind of varies throughout these different layers. Obviously, as you get further away from the Earth, because your Earth is absorbing heat, so that's why as you get further away, it kind of the temperature goes down, but then it kind of slowly jumps up again. The reason why it goes a little bit more as you get into the stratosphere is because of that ozone layer. The ozone layer absorbs UV radiation, which also contains heat, so therefore it drives that temperature up a bit in the stratosphere. Well, then just like the troposphere, as we get further away from that ozone layer, the temperature goes down again. And then the reason why it goes very, very high up here is because now there's nothing protecting it as it's closest to the sun, so it's going to continue to increase as the closer we get as far as distance to the sun. So that is kind of the reason for temperature variation. If you look here as far as pressure goes, we have the most pressure in 1,000 millibars at ground level, and then it kind of just exponentially gets lower and lower all the way to 0 as we reach the top end of the stratosphere. So that's kind of the makeup of the atmosphere, and just wanted to go over that with you with this first section. We'll see you guys next time for section 18-2 when we look at outdoor air pollutants.